All right. We talked about opening a file. We talked about reading from a file. You could read a line, you could read lines, you can read the whole file into a string. By the way, as a note, if you were looking at I showed you how you can like read a file in a for loop, right? Where you put the file name in the for loop and then it just reads one line at a time, which is great. Often, my recommendation is if you want to read from a file, I should have mentioned this last time, I didn't. If you want to read from a, remember how I showed you you read from a file and you want to start over, you have to like reopen the file. You can read one direction and then if you want to go back and read something you just read, you can't. My recommendation is don't open a file and read it line by line, no. Open the file, read the whole file into a string, and then manipulate the string. That's my recommendation. It's a little easier. Anyways. We also saw you can write to files, which was kind of neat because the file didn't need to exist. Python would create the file, you could write to it. But I also showed you got to be careful about writing to files because if you don't close your files, you might not actually write to the file, right? Because your buffer hasn't been flushed. So, right, you want to read from a file. If you don't close those files, not that big of a deal, but you really should. When you're writing to a file, close your files. That's where bugs can happen. And you'll look at your code and you'll be like, well, there's nothing wrong with my code. And you're right, except that you didn't close the file and that has some implications. That's all. The next topic here is comma-separated values, CSV files. These are a common one. The Starbucks data was in a CSV file, right? It was like starbucks.csv. And that's a comma-separated value file, which is neat. With CSV files, if you open them up, like let me show you what I mean here real quick. If I go, oh no, I don't have it installed here really. You know what, maybe I can find one from here. Resources. Yeah, so these are CSV files. If I open them up, this is what they look like. The fact that there are numbers in here with all this, you can kind of ignore it. But it's just a text file. But what you have is each line in the text file. So a CSV file is to store like tabular data. And when I say tabular, I mean like data that you can kind of think of as being stored in a table. Pardon? Exactly, just like an Excel spreadsheet. So each line corresponds to like a row in the table, and each column is separated by commas, right? So you see negative 3.16 blah, 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 comma. 3.632 blah, 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 comma. 1.823235 blah, 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 blah. So this is like a table with a lot of rows. How many rows does it say? 101 lines. And probably 100 lines. The last line's probably empty. And 3 columns. And what's neat about CSV files is if you have like a spreadsheet program on your computer will want to open it up in like Excel or any similar software if you have it. And it'll even parse that data for you and represent it like it's in the table, which is really nice. Now, mind you, this is not an Excel file. If you want to start doing like, oh, okay, well, what's the sum of everything there, right? And you're like, oh, wow, it's a big number. Negative 860, great, cool. That's the sum of that whole column. And you can do this type of Excel type stuff here. But if I were to save this file as a CSV file, no equations are saved here. It is not an Excel file. It really isn't. It's just Excel's kind of loading up a CSV file because it's a nice and easy way to look at the data. But it's not actually an Excel file. It really is just a very basic, don't save, just a very, very basic text file. But the convention is separate columns with commas, and each row is a new line. Great. And CSV files are a great, absolutely fantastic standard format for saving tabular data. Sadly, people have really perverted CSV files where instead of using commas, they'll use tabs, which makes perfect sense, right? Separate your values with tabs in your CSV file. All right? But people do it. People will invent their own file formats all the time. They really need to stop. Another one that gets wild is sometimes, and I kid you not, I've been working with it. This has been I would say, most of my time on Monday that I had working on something, like code, was spent dealing with a really bad CSV file format. And the bad news is this format came from Fitbit. So this was Fitbit outputting this data. And Fitbit did a big boo-boo, in my opinion. What they have is they have a CSV file. They give you a CSV file. But the problem is, you know how like sometimes, if you've got a big number, you separate like every third order of magnitude by a comma, right? If you have like 3,000, you write 3,000. Well, they had a CSV file, but they also included commas in their numbers, meaning their CSV file was absolute nonsense. If you try to load that up and it's going to have all these issues, it's absolute garbage. Who in their right mind did that? They should be punished. They're evil people. But all right, fine. You work around it. You make it work. Keep your CSV files nice and simple. Data, comma, data, comma, data, comma, data, comma. New row, new line. Simple. What's nice about CSV files is they're a very typical common file format that everyone's kind of used to. So much so that Python even has some built-in libraries for reading CSV files really easily. Right, okay, so here's me showing you, here's a CSV file. Imagine I had one that looked like this. You could think of it as a table like this, right? Cool? It's the same data, just one's more explicitly shown as a table than the other. But if everyone's happy and following along, I don't mean you, I mean everyone in the world following along with the CSV file format strategy, that's just what it means. Great, keep it simple. If you want to read a CSV file, well, here's an example from this assignment 1. There's actually something we can import CSV, that actually, it's a file reader, but if you wrap that file reader in as like a CSV reader, it makes reading the CSV even easier. And here's an example of doing it very nicely. You could do this a bajillion different ways. This is a very verbose way that I think makes it pretty clear step by step. But if you have CSV data, my recommendation to you is go look at assignment 1 and copy what I did there to make it work for what you need. Which, by the way, and I think I said this last time when talking about debugging, but it's always good, in my opinion, to reemphasize this type of thing. That style of like solving your problems coding by finding a solution similar to what you need and being able to change it for what you need is really good. Here's a bit of a motivational pep talk for you. Raise your hand. So let's say you've been debugging, right? And you come across a problem and you really don't know what to do. You know what you want to do. You know what your problem is. Maybe it gave you a bit of an error message, maybe not. But you're kind of stuck. You're puzzled. And so you go and you maybe do a little Googling. And maybe on Stack Overflow. Raise your hand if you've stumbled upon Stack Overflow before. Okay, great. Stack Overflow, it can be helpful, although sometimes you get some real assholes that want to prove how smart they are to everybody else on Stack Overflow. So bear that in mind. But you find someone on Stack Overflow with a very similar problem to what you have. It's not quite exactly the same. It's very, very, very similar, though. And you look at their code and you go, okay, I know what they're doing. I know what they're trying to do. It's similar to what I'm doing. And oh, here's someone's solution. Great. And the solution that they gave them worked. You see that maybe the OP go like, oh yeah, perfect, thank you, great, right? Solve their problem. And you can see how that solution made it work. And then you can see the solution that the person recommended, and you know it's not going to work exactly for you, but you know that if you take it and do this and do that to it, it should work, and you do it, and then it works. Who here's done something like that before? Raise your hand really high. I want to see. Put your hand up if you've done that. That's phenomenal. Everyone who raised your hand, whether you like it or not, you're pretty good at computer science. Whether you like it or not, it is. So for everyone who rose your hand, I got some bad news for you. If perhaps you're not doing as well in this course as you would like to be, and your excuse has been, well, I guess I just don't get it. It's not for me. I don't get it. You're full of shit. If you can do that, it is for you, whether you like it or not. You're good at this. And your excuse of, I just might not be good at it, that's why my grade's bad. No, that's not why your grade's bad. You get it. Maybe just, come on, lift yourselves up and get at it a little harder, but you definitely get it. You can't use that excuse of, I just don't get it. No, if you can do that, you get it. Because that is what we call in the computer science pedagogy, and pedagogy is just a fancy word for like how we teach computer science. That right there is like the pinnacle. If a student can understand the problem they want to do, understand why it's not working, find a similar problem, understand the problem someone else has, and see that it is similar but not quite the same, understand what they're trying to do, understand a solution that someone has given them, is capable of taking that solution and modifying it such that it works for their problem, you get it. You understand computer science. Like I said, whether you like it or not, you're good at this. So you should be doing well in the course. If not, find out why. But it's not because of the excuse of, oh, I just must not get it. No, you do. If you can do that, you are in great shape. If that's like the #1 skill you learn this semester, I've succeeded. Because that right there is, keep up the good work. You get this. If you can do that, the amount of understanding and skill that takes is phenomenal. So keep up the good work. Keep doing that type of thing. Obviously, don't do it to the point where you're not learning anything. Sometimes, you do that, and maybe you don't quite understand the solution, but you copy and paste it, and it really did work, and you go like, thank God, whatever, I'm moving on. I get it, that happens sometimes, but make sure that's not your typical strategy. Make sure it's from a place of understanding. So why did I get onto this rant? Right, is if and when you need to read a CSV, just look at someone else's example and hack it to make it do what you need to do. If you can do that, you're golden, all right? That's not cheating. That's programming. Cheating is a little bit different. And if you're saying, well, I don't understand the difference, then I go, come on. Stop lying to yourself. I think you know the difference between cheating and not. And you've known since this big, right? So, all right, yeah, great. Loading, okay, cool. CSV. All right, here we go. Okay, here. If you're following along, raise your hand if you're following along right now in the course notes. Perfect. Then we're going to do this. Download the CSV file, airports.csv. Okay. Show in folder. There we go. Cool. And then, oh, there's the Starbucks one. Oh, here. This is what I want to do. So, okay. Upload. Okay, upload. Download the file and upload it to Colab. Downloads, airports.csv. Great. Yeah. Cool. And if I open it, look at this. This is pretty cool, actually. Remember how I was able to open the text file in Colab and it showed me the text? If it's a CSV file and you open it in Colab, Colab will even kind of show it to you in like a table style, which is really nice. If you go open the file, it's a CSV file. There's no table there. But Colab is just formatting it like a table, which is really nice. Okay, so the data's there, great. Write a function called load airports that loads that CSV file. You can hard code the name in. And return a list and returns the list. Use Starbucks. Yeah, here we go. And use this as reference, okay? Basically, take this function, Call it load airports and make it do similar thing, but load the airport data into a list of lists. Or it could be a list of tuple, whatever, it doesn't matter. But I'll give you a few minutes to do that. I want you to get a little feel for loading the data. I'm actually going to do it with a file name. Raise your hand if you're done. Cool. Raise your hand if you'll be done in like 30 seconds. Cool. All right. We'll keep working at it. Here's my solution. I basically condensed the Starbucks one. I also didn't bother converting it to a tuple. Airport will be a list that represents a whole row. So I just took that whole row and added it to my outside list. Also, there was no need to convert the strings to floats because the strings are supposed to be strings. If I look at the output here, you'll notice that it includes this kind of like a header row. In fact, I'm pretty sure there is such thing as like a CSV. I think there is like a header. No, maybe not. But that header row, sometimes like the columns are labeled, that's fine. And maybe the data that you're returning from this function, you really want those labels, that header row to be there. If not, well, you know, simple, just do everything from index 1 to the end. If I do that, this should eliminate, yeah, this eliminates the first one. Great. Any questions about this implementation right here? Now's the time to ask, because I'm about to simplify this a lot, and maybe you'll like it, and maybe you'll hate it. I don't know. Yeah? If you're using a CSV file, a CSV reader, that will do that for you. So maybe something else has gone a little wonky there. Any other questions? All right, I can actually simplify this a little bit. You can actually, Python is smart enough to say, there, cool. Python's smart enough to let this work. Now, I didn't do this in assignment 1. If I were writing code to actually do this, I would do it this way. I didn't do it this way on assignment 1 because I thought that's just even more weird to inexperienced programmers, right? And when you're working on assignment 1, I don't want to spook you. So you can actually take a CSV file reader and convert it to a list, and Python's like, okay, yeah, I'll do that for you. They just want everything as a list. Great, cool. Great. So that's actually pretty handy. Now, this works quick and dirty and easy if it's just string data. But now, what if some of the data in that list of lists I want to be floats or something? Okay, well now I need to go and actually convert them to floats. Or maybe it would have been better off to do it in a loop and convert them to floats every time I added it to the all airports list, whatever. But there, cool. Any questions about doing it this way? And again, if you were looking down when I said it, I'll say it again. This part right here, the fact that I'm doing the slicing, I'm saying start at index 1 and go to the end. All this is doing is say, return everything in the list except the first row, the first element, because the first element was that like header row, and I didn't want airport name, airport code, airport name. I didn't want that included. I'll run it again just to make sure it's clear. When I run it, see how the first element in the list is airport code, airport? If I open up the CSV file, I'll show you. See? Look, even Colab is smart enough to know, like, oh, that first row is the header row. So see, it's even like stylized a little different with a bolder line underneath. But I didn't actually want that data. I didn't need the header rows when I loaded it in, so I just got rid of it. That's all I was doing by that. It's nothing particularly sophisticated. Okay. Any questions on this before I carry on? No, I'm actually curious. I want to check something. Amazing. Absolute amazing. Sweet. All right. Now pretend you didn't see that, and do the next activity. Okay, wait, here. Write a function, get name from code. Okay, here we go. Shh. All right, fine. I spoiled the fun. All right. We can do this activity in 2 seconds by explaining it. I would encourage you to do this as an exercise, but for the sake of time, I'll just explain what I was going to do. I was going to say, look, if I told you, great, you've got all this data. You've got a table of data basically stored. I realize you have a list of references to other lists of strings, right? But we're thinking of it as a table. Where one, you've got airport code, airport name, airport code, airport name, right? YYZ, Pearson International, right? That's the idea, okay? If I say, write a function that takes an airport code and give me back the corresponding airport name, what you're going to do is a linear search. Okay, your function takes the string, the needle. The list of airports is the haystack. You look at each element in the haystack, which is a list of length 2, airport code, airport name. You take index 0 of that airport list and check, is it the needle? If it is, return the airport at index 1, which is the corresponding name. That's all, right? But I would need to do a linear search. If there's 100 airports, I got to look through all 100 airports to guarantee that I find or don't find what I'm looking for. But if I were to tell you to do this with a dictionary, there's no linear search. I've already given you this rant already, right? But if I had asked you to do this, the right choice here is a dictionary. That is the correct choice. If on an assignment I asked you to do this, or if on a test I asked you to do something like this, and you loaded this data up into a list of lists, you wouldn't lose any marks. I would be like, yeah, it's fine, right? Now, if this was next semester, you might lose a few marks for like, you should have done it with a dictionary, okay? But here, I'm not expecting you to be able to go like, I know a dictionary is the right tool for that job. We're still just learning this stuff, right? So don't be too worried. But realistically, the right choice in this particular situation, I would say, is use a dictionary. The airport codes are unique. And if I want to have to search through that data, don't make me search through it. Just look it up constant time with a dictionary. That's what you do. Now, I didn't actually, what I was just doing right there a moment ago when I was here, and I got all giddy when I did this, and it worked, is I didn't know it would work. I didn't know that it would be smart enough to say, okay, the first column is the key and the second column is the values, right? But it looks like Python, my data was formatted in such a way that Python was happy to do that. It actually, look, ABE is the key for Allentown, Bethlehem, Easton International, right? I have no idea where that is, but whatever. I assumed it was like Albuquerque or something, but whatever. Someone look up where that is. I have no idea where that is. I just want to know. Oh, there's Albuquerque. If we go all the way to the end, nope. Oh my God. Halifax. It's there. YHZ. Let's test it. A at YHZ. Halifax. Great. Cool. So yeah, in this situation, I would say use a dictionary. It's the right choice. If you used a list of lists and you did a linear search, fine. Not too big of a deal for us. And then writing to a CSV file. If I have data in a list, I could write to a CSV file. In fact, I'm curious. I actually have no idea how this is going to work. Let's see what happens. Let's say, okay, csv.writer. Oh, was it only in the function? Yeah, it was. Okay. Writer, open. Write rows. So write row will take a single list and like add it as a row in the file. And if I called it again, it would the next row, the next row. Write rows will take a list of lists that will do several, all of them. I actually don't know what's going to happen if I give it a dictionary. This is why I'm curious. I want to know. Let's see what happens. Now, okay. Also, oh, didn't look good. Now, this wasn't a case of, this should not have been a case of me not closing the file. When you use CSV Reader and CSV Writer, those actually deal with the flushing for you. So it's only when dealing with like raw files that you should be worried. When using CSV Reader, CSV Writer, I shouldn't have to be worried about closing. But the fact that nothing got written makes me sad. So let's go back and change this into a list. This clearly won't work, but that's fine. I'm wondering, is it because, hold on. Okay, cool. There, great. So now I read the file, and then I immediately wrote it out. I said write rows, which take a list of lists, a list of references to lists, I know. You can do an individual row, right? It would also work fine. Any questions about this? Cool. All right. What time is it? 6. Okay, we got some time. You've all seen various exceptions in Python. Now, really, exceptions aren't necessarily errors. Now, in Python, they call their exception errors. Fine, they do. But they're not necessarily errors. Like this right here is an example of an exception. If I try to convert the string hello to the integer, to an integer, it's going to go value error. I can't do it. Whenever you see something like this, that's what we call an exception. But it's not necessarily an error. Now here, it's clearly something's gone wrong. But really, exceptions are exceptional situations. Something funny has happened. That's the point of exceptions. Now, I'm going to warn you. This topic tends to confuse some students, but I'm convinced that the reason it's confusing is because the students aren't fully paying attention. Because I think if you follow along, it should be straightforward, not trivial. So I'm not trivializing what I'm about to explain. It does require you to pay attention and listen, though, to understand what I'm talking about. So exceptions are exceptional situations. Something funny has happened. Here's another type of exception. I'm trying to index a list at an index that doesn't exist. So it's saying list index at a range. Both value error and index error are exceptions. But there are a lot of different types of exceptions. How many times have you seen something error when you've hit run? A lot? A lot. Yeah, those are all different exceptions. Sometimes they're caused by bugs, but sometimes they're caused by something exceptional happening. Something funny has happened. And the problem is, again, they're not necessarily error. And when Python is showing you value error, that means that something funny happened in your code, and Python is letting you know, the programmer, that something exceptional happened. What do you want to do about it? Right? And if you, the programmer, don't explicitly do something about it in your code, which I'll show you about in a moment, if you don't write code to manage exceptions, it gives the exception like literally to you, for you to read. Exception. Something funny happened, what do you want to do about it? Because the Python can't read your mind. So it just lets you know. So if I'm the one that wrote the code to convert the string hello to an integer, what should I make my code do? Okay, hold on, okay. If I'm the one writing the code for converting strings to integers, right? So I wrote a code that has a function that converts strings to integers. What should I make my code do if someone asks my code to convert the string hello to an integer? I could write a function that takes some arbitrary input and converts it to an integer. But that doesn't stop some asshole from showing up and giving you the string hello, going, hey, I'm going to break your code. Because your code wasn't supposed to deal with the string hello. It was supposed to deal with strings that were integers that can convert to integers. Just like the code. So when I'm saying you wrote a function that converts a string, like an integer string, to an actual integer, well, you don't actually have to write that one. Someone else already wrote it for you, right? And you've been using it whenever you wanted to convert something from a string to an integer, right? But when the person that wrote that code wrote it decades ago, they were put in a position where they had to ask themselves, what do I do if somebody tries to convert the string, like if they give me something that I can't convert to an integer? What do I do about it? There was a human being sitting in front of their computer going, what do I do about that situation? Somebody gives me something, right? And then you're saying, well, obviously it's not going to work. It crashes the program. But someone had to make a decision that if this happens, crash the program by raising this exception. Because they're put in a position where they have to ask, well, what do I do about it? Because there's no obvious answer. Other than, okay, stop running. But should my code simply ignore the request? Maybe. Ignore and carry on. That could work. Should my code crash the whole program? Is this something catastrophically bad that if this happens, my program should stop running altogether? Should my code crash? Maybe some user entered the input wrong. Maybe the user should be given a chance to re-enter that input. Maybe the issue is actually with the text file that I was reading. Maybe the text file got corrupt. The list goes on. Why this happened and what the programmer wanted, assuming good faith, that they're not trying to break the code, I don't know. So I'm sitting there in 1991 writing the code to convert strings to integers. And I'm thinking, in 2023, some student wants to do that, but they give me the string hello. But obviously I can't, what do I do? I'm writing the code in 1991 to convert strings to integers. But what do I do in 1991 for the person in 2023 that wants to do this and something goes wrong? What do I do? And if you're sitting going well, how? He can't read their mind. That's the point. They can't time travel and ask you in the future, what do you want to do? And what should happen is going to depend on the situation. I'll walk you through some examples on this. Yeah. So the trouble is, if I'm running the code to convert strings to integers, I can't possibly know what you, the individual trying to use my code at some point in time in the future, wants to do with this exceptional situation. I got some input I can't convert. What do I do? What I can do Here's the only thing I can do. I can raise, this is a keyword we use, we raise the exception, which then I give to the programmer in using this function. All the exception does is it creates this exception. Think of the exception as like a ball. So what I do is I'm like, okay, you gave me the string 11. Okay, well, that's the integer 11. You gave me the string 44. That's the number 44. You give me the string hello. I can't convert that. What do I do? Should I crash? Should I tell them to try again? Should I, et cetera, et cetera, et cetera? What do I do? Here's what I'm going to do. I'm going to create this exception, this ball. That means something funny happened. And I'm going to throw it at whoever, like let's say you called this function. You gave me the string hello, something funny happened, and I go here, something funny happened. And now you got it. And now it's up to you to say, okay, that function that was written in 1991 communicated to me that something funny happened, something exceptional happened. What do I want to do today in 2023 about it? Do I want to crash? Do I want to try again? Do I ignore it? That's for you to decide. All I can do is inform you that something funny happened. I can't solve your problem, but I can make it easier for you to solve your problem. That's what exceptions are all about. Consider this example here. Divide. If the denominator is 0, we raise a 0 division error. You can't divide by a 0. All right? You can't. So if I wrote this function divide, I can raise this exception. I wrote this function in 1991. All of you are using this function, great. But someone accidentally or maybe intentionally gives me a divisor of 0. What do? I can't do that. I can't divide by 0. So I raise this exception. What to do, everyone in this room could be using this function to solve some various problem that they have. What you need to do if divide by 0 happens depends entirely on what you want to do about it, not about what I think you should do about it in 1991. So you have to decide, what am I going to do? If you divide by 0, I let you know there's an exception, you catch it, what do you want to do about it? If you divide by 0, you're doing something entirely different, here's your exception, you catch it, you deal with it accordingly. The exception is really just some like message communicating ball, some thing we can throw around. Then, oh look, I said 1991 and that was the example I had. Huzzah, nice. If you're using this today, you call divide 9 by 0. You can't divide 9 by 0 though, can you? That doesn't make sense. It's not defined. So what do I do in 1991 about it? I can't. There's not much I can do considering you're the one using the function for whatever you want to use it for. I don't know what you want to do. It's more than 30 years in the future. I don't know what to do. What do you want to do about it in the future? How can I know what you should do about it in the past? In the future? Whatever. You know what I mean. Here's what I do. I create that exception, I give it to you. And then your code that's using my code, being aware that my code might raise an exception, you can write special code that handles the exception, that catches the exception. So in Python, it's called raising an exception, and then you accept the exception. In other languages, like in Java and C and C# and C++, they call it throw an exception and catch the exception. The function that has the exception throws it. The function calling the one that had the exception catches it. Right? So that was the ball example. So what is your program supposed to do if this exceptional situation happens? Should it crash? Should it read input again? Should it carry on if nothing mattered? Imagine you're writing code for a helicopter. And it's reading all these sensors and whatnot. And every once in a while, it reads from a sensor and the denominator is 0. Should the program that is keeping your helicopter in the air say, divide by 0 error, crash, stop running? Should that happen? No, I don't think so. Or let's say it's just some silly little program that reads some input and it does some fancy little output. What should your code do? Should it crash? Maybe. Or maybe you can handle the exception by just ignoring it. You, the programmer, explicitly says, okay, catch the exception. I acknowledge that it exists. I'm going to just ignore it. It doesn't matter. It's a silly little program. So maybe that's what the helicopter should do. It's just, okay, whatever. It read from a sensor. It was 0. It doesn't matter. Ignore it. Or maybe you've got some very sophisticated medical device that applies radiation therapy to people and something went wrong, something exceptional happened. And it calculates that the person should get an insane dose of radiation. Should your program just ignore that exception? Probably not. Your program should probably, in that particular scenario, immediately crash and don't apply dangerous levels of radiation to people. What you want to do today is up to you. It's not up to the person in 1991. All right, we'll end here.